Hello, ATS 114 TAs. This is Dr. Shragi, and I'm just going to walk you through a little bit about how to do this weather map analysis lab. It's mostly a light skills kind of lab. The students usually get a little frustrated because they haven't done things like this before, but that's okay. That's part of the purpose of a lab is to show how to do different things that they haven't done before. The first part of the lab activity involves decoding and actually drawing a little bit about station models. Remember, station models are those clusters of weather symbols and numbers on a weather map at each station showing the data that the station reported. Remember that the number at the northwest corner of the station model, that is the temperature in Fahrenheit. The number in the southwest corner is the dew point. The symbol here is a weather symbol that reports the kind of weather that they're having right now, if they reported anything. You get those weather symbols from Appendix C in the text in the lab manual or the inside back cover. I think it's page 243 and 244, if I remember right. Anyway, there's a whole mess of these kinds of symbols, and they just decode to various things. If they didn't report, they didn't report. Like this one here, there is no weather symbol. The main thing that students hate is these symbols again for pressure. Remember, if you have something like 024 is the pressure code, you put a decimal place right there. Now it's 02.4. Then you either put a 10 or a 9 in front of there, whichever number it takes to make the number closer to 1,000. So in this case, it would be a 10. Your pressure here is 1,002.4 millibars, because if you had put a 9 there, you would have gotten 902.4 millibars, which is farther from 1,000. All right, so these guys, between the key on page 103 and the appendix at the back of the book, they should be fine on these activities about decoding the station models. What they will be a little bit more stressed about is this business of contouring. I apologize, my tablet is being really slow of loading up the manual today. Um, when you draw contour lines, you guys all survived ATS 114 yourself. You know how these contour lines work. They are lines of constant, in this case, temperature here. So what they are wanting in this little example here on example 9.2 is they want them to contour every 5 degrees, and they've already drawn in the 80-degree contour for you. Notice that the 80-degree contour goes exactly through each of these stations where the temperature is exactly 80 degrees. And when you draw the 75-degree contour, it turns out all three of these stations here have a temperature of exactly 75 degrees. And it turned out all three of these stations here had a temperature of exactly 70 degrees, which sounds pretty neat and pretty easy. Of course, that's kind of a fake thing they did here, right? I mean, the temperature would not normally be exactly the same as this contour line, but it illustrates that that's the purpose of these contour lines. They are every place on this isotherm where it is exactly that same temperature. So everywhere on the 75-degree isotherm, the temperature is exactly 75. Every place on the 80-degree isotherm, the temperature is exactly 80, and so on. But of course, in general, they won't. The stations don't will have temperatures different than the isotherms that you are drawing. So, like for example, if I just take this diagram right here, when they were ready to draw, let's just say let's draw the 40-degree isotherm here. When they drew the 40-degree isotherm on this diagram, they want it to be exactly 40 degrees on the isotherm. They want the isotherm to be like a fence that separates stations that are less than 40 degrees from stations that are more than 40 degrees. So like when they started drawing this here, okay, it should definitely go right through this station where, well, okay, these are actually isodrosotherms. They're lines of constant dew point, but you get the basic idea. They're still drawing contours. So, like for example, the isotherm here should go between 37 and 44, because someplace between those two stations the temperature is 40 degrees. Someplace between these two stations the temperature should be exactly 40 degrees. Someplace between these two it should be 40. And it actually in this case makes a loop where every place inside of here the temperature is less than 40, and every place outside the temperature is more. Okay, so these are pretty straightforward. Again, you guys survived ATS 114. You know that these are a little bit of challenge to draw, but it's not that big of a deal. Honestly, in the video that I've made for the students, it's a little more, it's a little easier for me to explain it than on this diagram here. But like for example, here on diagram 5, they want you to first draw the isotherms, and they have actually highlighted the northwest corner of each of those station models so that you can see exactly where the temperatures are. So like let's say we want to draw the 50-degree contour here. Okay, 50 degrees should be someplace between 45 and 54. Should be someplace over here between 48 and 57. Should be someplace over here closer to 48. 50 degrees. Let's see. So it's going to go someplace between 42 and 61. It's going to be someplace between 48 and 66. And you just keep, it's going to go right through this station where it's 50. And then make sure you label it as 50 degrees. And then, like, we could draw the 40-degree isotherm here. Let's just see if I can do it. 40. And actually, 40 goes through here as well. Something like that. So that would be the 40-degree isotherm, and there's no 20. Let's see. Let's draw a 60 in here while we got everybody's attention. 60 goes through about like that, because it got 60 degrees on one side, and more than 60 on one side, and less than 60 on the other. And in fact, in this case, there is some areas that have 70 degrees, something like this. Okay, it's hard to do that with your finger on tablet screen, but anyway, you get the basic idea what that will look like. And they just get some exercises in doing that. And as you'll see in the student copy of the video, they also draw some isotachs, which are based on the wind barbs on a station model. But it's all pretty straightforward. I do want to draw your attention to the fact that there are 3 questions I don't want you to have them answer. They're way too technical. And I know from past experience, the students don't do it very well. Since my tablet is having a hard time loading the pages quickly, let's just tell you it's going to be questions number... Hold on. It'll be questions number 11, and let me see here, 15, and 16. These 3 questions are actually really interesting questions, but they're beyond the scope of the class, really. Well, they're on the high end of what the students should be able to do, and frankly, I'd rather them spend more time on the contours and the decoding of the station models and the working with wind barbs and so on, and less time worrying about these rather complex questions. Okay, that's all I needed for this lab. I think it's going to be pretty straightforward. Make sure you watch the video I made for the students. I think I have a better explanation of contouring over there. And please let me know if you have any questions. Thanks for all you do.